Today we're going to do start with probability. So we're going to start off with some probability, kind of going back and reviewing a little bit of the probability that we had before. That was a long time ago. And then we're going to kind of expand from that. So really we want to try to cover like 3 units. Probability, we have a geometry, and if we have time we'll finish with a algebra 1 type of unit or an algebra type of unit, okay? So that's kind of our goal. So this probability document that I have in front of me should be available for you. So if you go into Google Classroom, and there should be a material document that I shared with you, and it should be called Probability Unit 1. And it is just like our book, right? Or just like the material that I would be giving to you normally. So we're just going to go through this. You know, it's not for you. It's just kind of for you to look at. If you have a printer and you want to print it, you can. You don't have to. I'm just giving you some visual information that you can read through or follow through as we are progressing. And then we'll do some things along with that in a typical integrated math fashion. Man, it's just great to be here. I wish you guys were all here right now. So here's what we're going to do. Again, we're going to talk about some probability, all right? And so normally I'd have somebody read this paragraph, but since nobody's here, maybe I can get a guest to come in and they will read this for me. So we can think about how many games that use roll die or dice to play. You can think of some Monopoly, Cruel, Trivial Pursuit, D&D games, so forth. But some games are played with a set of die or a set of dice, require no board whatsoever. Let's examine some probabilities. So, our discussion question, thank you, by the way, Mr. Guest. Discussion questions, number 1, what is the probability of obtaining a 3 roll in a die? So we're talking about a standard die, right? A cubic die. So if we look at that, we know that there's only 1 3 on there, correct? And we know that there is 6 possible things, okay? So there's 1 3, and there's 6 possible outcomes, so it would be 1 out of 6. So most of you, I don't really like the way that pencil wrote very well, so maybe I'm going to go back and try one of these pens. I'm kind of liking this color, though. All right, so let's try this out. Maybe this would be better. But there's 1 3, 1 3, okay, out of 6 possible numbers. What is the probability of rolling an odd number? All right, so now we know that we have odd numbers like 1, 3, and 5, right? So we know there's 3 of those over 6 possibles, all right? What is the probability of rolling a 2 or a 4? Again, so that'd be a 2 and a 4, so that shows up twice over 6. Notice that I'm not reducing these. You can, but again, I'm not interested in that you can reduce fractions. Everybody should be able to reduce fraction. What is the probability of only 3 4s in a row? Oh, well, that's a little bit different now, right? Because in this case, we're not just rolling a die once, we're rolling it 3 times. So that changes things a little bit. So this last one might be a bit challenging, but for some, review of probability from the lottery module might be helpful here. So let's go down and look at this. I have to do this. Sometimes I forget. All right, so here's a cool little math note that we have. All right, and I'm going to get the highlighter going. Experimental probability. We might remember that from the lottery unit. Okay, I'm going to click this here and get this to be a little bit thinner. There we go. All right, so experimental probability is the number of times the event occurs over the total number of trials in a simulation. So if we wanted to find the probability of the ones that we had up here, right, and we just didn't know those, we could roll a die and we could count how many times that we get a 3, for example. We could roll it 20 times. You got a lot of time on your hands now, right? So we roll a die 20 times. We figure out how many times we get a 3. That would be however many times we got it over 20 times because we did it 20 times. Again, we did this in the lottery unit. You just have to think back a long ways. Theoretical probability, so let's talk about that. The theoretical probability, I'm going to change this to green now, all right, is right here, okay? So theoretical probability is the number of times the event occurs in a sample space over the total events in the sample space. So theoretical probability is what we were using when we were finding the answers to these questions. Right? I remember saying, well, hey, we got 1, 3 on a regular die, shows up once out of the 6 total numbers we could get, so that would be 1 out of 6. That's theoretical probability. It's probability that we understand or already know. Okay, that's theoretical probability. And here it talks about, for example, consider question 4. To find the experimental probability, one could design a simulation to roll a die 3 times and keep track of the number of times that 3 4s occur. So let's say that somebody did this. Again, they got a time on their hands, right? So they keep going. They roll the die 3 times. Here's all the different outcomes they have. My goodness, there's a lot of different outcomes. Finally, they get the 4 4, all right, that they were looking for right there, all right? So let's count how many times it took before they got that. So if we count, right, and see how many rolls of 3 die they did, or of a die 3 times, then we see that it was 22, all right? So that means that the experimental probability of that happening, all right, is, I lost my pen, there it is 1 out of 22, okay, because I have 1 4 4 4 out of a total of 22. Now, theoretically, could we have figured that out? Well, that's what we're working towards, okay? We're maybe not quite there yet, but we're working towards that. Let's see what it says. To find the theoretical probability, we first need to find the sample space. Consider that one die has 6 different outcomes, so one possible outcome for rolling a die 3 times would be 1 1 1. Listing the complete number of outcomes would be real tedious and take a long time, so we need a better way. All right, so we're zipping along here a little bit. Again, you can pause this at any time. All right, let's consider the first roll. How many different outcomes could there be? What about the second roll, and what about the third? So this should look like this. So if we have a die and we're rolling it, right? Okay, and so we know that there are 6 different outcomes we could have, right? 1, 2, 3, 4, 5, 6. So we know that. Then if I roll the next die, or maybe I'm rolling the same one, it doesn't matter, all right, I get another 6 possible outcomes. 1, 2, 3, 4, 5, 6. Then if I roll that again, I get another 6 possible outcomes, all right? So I put little dots in here because I'm going to multiply those, all right? So I can get 1, 2, 3, 4, 5, 6. And for every one of these 1, 2, 3, 4, 5, 6s, notice that this is not writing very well, all right, I could get 1, 2, 3, 4, 5, 6 again. So that's why I'm multiplying these. So I'm going to get 6 for each one of these, which gives me 36. And of course, then that's going to happen with the other one too. We're going to get 6, 6, and 6. All right, we multiply all that together, and we get 216 total possible outcomes in the sample space. All right, we're just looking for 4, 4, 4, 4. So that means we'd have one of those out of 216. There is the theoretical probability of finding that answer. Wow, that's crazy. All right, so 1 out of 216. So let's talk about this. Oops, there we go. Got to erase that because I forgot to hit home. How does the 2 answers we arrived at for the experimental probability and the theoretical probability compare? Well, shoot, we had 1 out of 216, right? That's the theoretical probability. I guess I'm not drawing here. 1 out of 200. Come on, there we go. 1 out of 216. There's the theoretical probability. Come on. There we go. But when I did it, okay, up on the top here, oh, I almost forgot to hit home. I get 1 out of 22. So that is not very, they don't compare very well. Now, I got to tell you, when I did this, I didn't really roll a die 22 times, okay? Actually, it would have been 66, because I would have had to go 3, anyway, it would have been a lot. I didn't really do that, okay? I was just making stuff up. Because I knew that had I went ahead and tried that, I could be rolling a die for a long time. And I just didn't, frankly, have enough time to do that. So, 1 out of 216 is the number of times that it would happen theoretically, and the experimental one was the 1 out of 22. If we were to try and roll 3 4s again, do you think the experimental probably would be the same? I'll let you think about that, right? What do you think, right? What do you think? Since I designed a computer simulation to roll a die 3 times and look for 3 4s, it was repeated numerous times. What do you think, that says supposed to be think, it says thin, would be the mean number of times it would take to get 3 4s? So if I designed a computer simulation to roll a die 3 times and look for 3 4s, right, and it was repeated numerous times, so I kept doing it and doing it. I mean, the computer was doing it, right? I'm just telling it to go, right? The mean number of times you would take to get 3 4s. So we did it 1,000 times. I'll let you think about that. All right. That question leads us to this, the law of large numbers, which says that if a simulation is repeated numerous times, the probability of the event would closely approximate the theoretical probability. So let's say we run into a problem, a probability problem, and we don't know the answer to that. Right? We don't know. Okay? So then if one way to do it would be to design a simulation and repeat it a lot of times. That's what we have a computer to do. Right? We don't want to roll a die, 300 times. No way. I don't want to do that. I want somebody to do it for me. I'll get the computer to do it. It can roll a die, and then I can figure out the probability. At least we can closely approximate it. All right, but the hardest part is coming up with, well, what's a simulation going to look like? And so we looked at some different things back when we did lottery. You might remember when we had the apples, green, red, and yellow apples, and we rolled die and we drew numbers and we did all kinds of things to simulate the green apple or the apple lottery. All right, so that was building up to the law of large numbers. Here's a little exploration that you guys are going to get to play with. Consider the game of Yahtzee. Now, some of you may have never seen the game of Yahtzee, and maybe you have. 5 dice are rolled, and different scoring options are available after rolling 5 or less dice 3 times. All right? So, let's take a look at the game of... All right? And we were talking about the game of Yahtzee. So I thought it would be best if we played it. I tried this. I finally got it to work a couple different times. I'm going to provide a link for you. It worked on the computer here. It worked on my iPad after I tried it a couple times. So let's go to it. I'm going to show you where you're going to go. You're going to go to yahtzeeonline.org. It's going to say Yahtzee Yams. You're going to click on...
Oh boy, is this great!
On that, play it. All right, here, let me see if I can go back. I hate to do this because it was just working. All right, just a minute ago. And let's see if it works again. All right, here it is. Well, of course, I got to go through this junk first. And so it's going to let me finally get rid of the ads. There we are. And now I'm going to play this. I put a link on there, and you can do this also. So let's see, it says play. All right, playing it. All right, let's see if it works. All right, so here's what I have. I have a scorecard that says 1, 2, 3, 4s, 5s, and 6s. All right, then I have 3 of a kind, 4 of a kind, full house, small straight, large straight, chance, and Yahtzee. So on the top part, what you want to try to do is get as many of those 1s, 2s, 3s, 4s, 5s, 6s as you can. If you get enough to where I think you get 65 or so, then you get a bonus, all right? Basically, if you get 3 of each one of these, and then you add that all up, all right, you get a bonus. 3 of a kind and 4 of a kind are exactly what they are. Full house means you're going to have 2 of one kind and 3 of another. Small straight would be anything that would be 4 of the die are consecutive, so like 1, 2, 3, 4, 2, 3, 4, 5. All right, but you only need 4. Large straight means all of them are consecutive. 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. Chance is just when you can't figure out anything else to do, and you do that. And Yahtzee is 5 of a kind. All right. So what I'm going to do is roll here. All right. So I roll, and I have 2 4s and 2 5s and a 2. So I'm almost at a full house. That's pretty exciting. So what I'm going to try to do is hold that one. Okay, so I'm going to tap on it, and I want it to stay. All right. Actually, I don't want that one to stay. I'm going to roll that one. I'm going to hold these ones. My bad. So I'm going to hold those. So I'm going to tap on them, and then I'm going to roll the 2. And if I get a 4 or 5, I'm in great shape. Oh, there it is. Okay, so I got the 5 I wanted. Yippee. I'm going to get the full house. I'm taking that baby, and there is my full house. Now I'm going to roll this again. This is fun. All right, let's see. Now I have 1, 2, 3, 5, and another 2. All right, and I could just, try to get a whole bunch of 2s here if I wanted to. But I also could get a small straight because I have 1, 2, and 3, right? And all I would need is maybe keep this one and maybe try to get a 4, right? Or I could roll them both and just try to get a 4. But you can see kind of where the probability of this is coming in, right? Because what would be my optimal move here, right? Would it be best to try to get a 4 by rolling 2 die? Or would I get a pretty good chance of getting a 4 by just rolling 1 die, okay? So, I mean, that's where probability comes in, particularly when you're playing games. And this is a simple game, but when you're talking about more complicated games, then it's a different situation. So I don't know what I should do here. Maybe I'll just go ahead and hold these ones, all right, and take a chance and roll. I mean, what the heck, right? Look at that. I got the 4 that I wanted. So now I already have my small straight. So if I hold that, I got one more roll. Let's go for it. Hey. I got 1, 2, 3, 4, 5. I ever tell you I was like really good at this game when I was a kid, right? So there's the large straight. I'm going to get that one. Okay, so I'm going to take the large straight because that's the one I want. All right, and I'm going to roll again. I'm just going to keep going because this is fun. All right, so I got 2 3s, 1 6, and a 5. Nothing excites me too much there. I do have a couple of 3s. The 3 of a kind, you could say, hey, why don't you go for that? Well, what it does is it gives you the score of whatever you got 3 of. So, for example, if I get 3 3s, that's only going to give me 12. But if I get 3 6s, that's going to give me 18. And the highest score wins. All right, so I want to try to beat the highest score. So, let's go ahead and try this one. Let's see, what should I do? I'm a little bit, maybe I'll just try to get a whole bunch of 3s. So maybe I'll hold on to the 3s here. And I'll roll and see if I can get some more 3s. Look at that. I got 3, 4, 5, 6. That's my small straight. I'm not even going to do anything more. I'm taking that baby right there. And now I have my full house, my large straight, and my small straight. So I'm going to roll one more time, and then you get to play. 1, 2, 3, 5, and 6. Man, that's just like a nothing roll, right? I got nothing there. So I don't know. I don't know what to do on this, right? So I guess I'm just going to keep one of these numbers and hope that something happens, all right? So I'm going to keep the 5, and I'm going to get rid of the rest. Right? And I got another 5. So, shoot, I'm in pretty good shape here. I already have my full house, so there's no reason for me to do anything with the 6 and try to roll it and keep the rest because I already got my full house. I'm going to roll with the 5. So I'm going to keep the 5s. I need one more 5. Come on, baby. Give me a 5. Oh, I didn't get it. All right, so here my option would be I could take this chance and get 18 points, or I could take my 5s and get a 10. I'd be taking a hit there. All right. There's a lot of strategy that goes into this. Remember, you want to try to get the highest number you can there for your sum, and then you'll get that bonus. So I don't know. I could take 1s and only lose 2 points because remember, if you get 3 of those, you've met that goal for each one of those. If I take my 2 5s right now, you think, well, that's 10. That's better than 1. You're right. But that means I'm 5 points down from getting that bonus, where if I just take the 1, I'm only 2 points down, and I might be able to make that up someplace. So guess what I'm going to do? I'm going to take the 1s. Okay, there we go. And I'm going to do one more, even though I said I wasn't going to. I'm just having fun. All right, so now I got 2 3s, 2 2s. Man, I'm getting a lot of full houses. This is craziness. It hardly ever happens. Let's see. I'm just going to go with the 3s. I'm going to hold those guys and roll it. All right. Oh, there's my 3 3s. Okay. So I'm going to hold on to that one. Here we go. Oh, I was smelling I might get a Yahtzee on that one, but I didn't. All right. This is how the game works. So what you should do is play it. All right. So go ahead and play a whole round so you fill in that whole card. Okay. When you're done with that whole card, all right, take a picture of it. Okay. Take a picture of that and send it to me. All right. That's what I want you to do. Yeah. Take a picture of that and either put it in, attach it to a Google assignment thing. It's going to say scorecard. If not, take a picture of it and send it to me. All right. That would be great. So let's do that. All right. Do that. And then we'll talk about tree diagrams in the next time. Okay. Have fun.